Alright, so let's look at some examples finding limits involving infinity. So for the first one, we want to find the limit as x is approaching infinity of 2x minus 3 over x squared plus 2x. So we already know we can't directly substitute into this because we can't substitute in infinity since infinity is not a number. So what we want to do is we want to divide everything that's inside this limit. We want to divide it all by the highest power of x that we have in our denominator. In this case, looking at this one, the highest power of x that we have is x squared. So we're going to divide everything inside this limit by x squared. So this is going to become the limit as x is approaching infinity of 2x over x squared minus 3 over x squared all over x squared plus 2x over x squared. Now let's simplify this. So this looks uglier than it really is. So this becomes the limit as x is approaching infinity. So 2x over x squared, we can cancel one of the x's out, so this gives us 2 over x. Minus 3 over x squared, we can't simplify it. Over x squared is 1. 2x over x squared just becomes 2 over x again. So now we're going to use our very useful fact, and in this case this is applicable, and so then we can take the limit as x is approaching infinity of every single term. So limit as x is approaching infinity of 2 over x, using our very useful fact, that's going to be 0, minus the limit as x is approaching infinity 3 over x squared, using our very useful fact, that's also going to be 0, over limit as x is approaching infinity of 1. Well, that's limit as x is approaching infinity of a constant, so it's going to equal to that constant. So it's going to equal to 1. Plus limit as x is approaching infinity 2 over x, using our very useful fact, that's 0. So we have 0 minus 0 over 1 plus 0, so that's 0 over 1, which then is 0. So notice in this case, remember our constant terms are not going to be impacted by x approaching plus or negative infinity. Alright, so let's look at the second one. So the limit as x is approaching infinity of 2x minus 3 over 7x plus 1. So same exact idea. First thing we want to do is we want to find out what is our highest power of x in the denominator, and then divide every single term by that value. So in this case, looking at it, our highest power of x we have in our denominator is just 7x. So we have an x to the first. So we're going to divide everything by x to the first. So this equals the limit as x is approaching infinity. 2x over x. Notice we're just dividing by the power of x, not by the constant. So 2x over x minus 3 over x all over 7x over x plus 1 over x. Simplifying now, so we get the limit as x is approaching infinity of 2 minus 3 over x all over 7 plus 1 over x. And so now, using our very useful fact where it's applicable, we're going to take the limit as x is approaching infinity of every single term. So limit as x is approaching infinity of 2. That's limit of a constant, so it's that constant, so 2. Minus limit as x is approaching infinity, 3 over x. Using our very useful fact, that's 0, so 2 minus 0. Over limit as x is approaching infinity of 7, which is 7, since that's a constant. Plus limit as x is approaching infinity of 1 over x, using our very useful fact, that is 0. So we have 2 minus 0 over 7 plus 0, so that's 2/7. Alright, for our third example, we have the limit as x is approaching infinity of 2x squared minus 3 over 7x plus 1. So first thing we want to do is we want to figure out what power of x to divide everything by. So looking in our denominator, remember we're always going to look in the denominator for this. So looking at the denominator, we've got x is our highest power of x to the first power. So we're going to divide every single term by x to the first power. So if we do that, so this is going to equal to the limit as x is approaching infinity, 2x squared over x minus 3 over x, all over 7x over x plus 1 over x. Simplifying this, we get this is the limit as x is approaching infinity of 2x minus 3 over x, all over 7 plus 1 over x. Using our very useful fact, so taking this by the very useful fact, then, so using very useful fact where it's applicable, limit as x is approaching infinity of 2x. So think about what type of equation that is. That's a linear equation with constant increasing slope, right? So it's constantly increasing, so as x gets bigger, 2 times x is going to keep getting bigger and bigger and bigger, right? So the limit as x is approaching infinity of 2x is infinity. So we have infinity minus the limit as x is approaching infinity, 3 over x. Well, that's going to use our very useful fact and become 0 over limit as x is approaching infinity of 7 is 7 plus limit as x is approaching infinity 1 over x using the very useful fact that's 0. So we have infinity minus 0 over 7 plus 0. So that's infinity over 7. Well, guess what? That's going to go to infinity. So what do we know about the limit as x is approaching infinity of 2x squared minus 3 over 7x plus 1? It does not exist, right? So it does not exist, but it does approach infinity. So we can say approaches infinity, but we know that limit does not exist.